Enjoy.
Yeah, thanks for having me here. Thanks for joining. Hope you had a good coffee and are fresh for the next talk. I'm Gunnar from JobMatch. I will talk about command query responsibility segregation and event sourcing in the Amazon cloud. So who is familiar with event sourcing in general? Many, and who wants me to give some more insight in depth into event sourcing? Who needs basic? Okay, I guess I'm going to be a bit quicker than that. Event sourcing, command query responsibility, segregation can be a complex topic. I could probably talk about a few hours about this. I'll try to keep my 40 minutes, but it's also technically, it can be a complex thing. So you need a decent reason to actually choose this for your implementation. And the reason shouldn't be like, hey, I heard about domain-driven design and somehow this event sourcing sounds cool, it's a new hype theme and I want to use this. And it should also, not be just for the technical, hey, fancy new stuff thing. So you need a why, a reason for actually doing this. And we had two core reasons. We are a startup, JobMatch is a startup. So we are learning in a yet uncharted domain. We are trying to establish our product. We are learning on the way. So every time we learn, we of course adapt our product, our technology, our software. So the system needs to be flexible. Those are the two core reasons why we went for event sourcing. But in order to give you the whole reasoning, I need to explain a little bit about the domain we're actually exploring within JobMatch. So JobMatch, the mission of JobMatch is to provide the non-academic workforce with good jobs. So how do we do that? Quite frankly, we don't know. We have a few clues, we even have a working product, and we provide people with jobs. But of course, it's a complex task. It's not totally easy to provide someone with a good job. And as a startup, we need to focus, so we are focusing on this type of guy, on a truck driver at the moment. So currently, JobMatch provides one platform for the business customers, the guys that are searching for truck drivers, and another side for truck drivers searching a job. Of course, I'm a software developer. Now, assuming I would approach you in the audience and say, what do I actually need to do in order to get a decent job as a software developer? Who is a software developer here? Any advice for me? What do I need to do to get a good job?
Go to a conference.
Yeah, okay, cool thing. I'm already doing that. Now, I'm a software developer. Now, my customers seem to be truck drivers. I don't have many friends which are truck drivers, actually none. So I don't know my customer. I'm working in a startup. Of course, what are we doing? We drive out on the highway, go out on the parking lot, and interview truck drivers. One of the typical questions I ask in such an interview when I knock on the door of a truck and interrupt the truck driver is, hey, sorry to disturb you, can I ask you a question? What do I need to do in order to get a decent job as a truck driver? Same as I asked you. And I might get some advice. That might be what you expect. But quite often, I get a completely blank stare and something like, hey, this is a shitty profession. Don't do that. Are you nuts? Why would you work as a truck driver? From the guy who's working as a truck driver. There are more than 500,000 truck drivers in Germany, 5 million in Europe. And this is a frequent response that you get when you talk with those people. There's another side of the equation, the trucking companies. Right, in Germany, there are about 20,000 trucking companies, Speditionen. So these are companies really busy with transporting goods from A to B via road using a truck. There are even more companies that are in need of truck drivers, like German postal services. They deliver parcels and letters. They, of course, also need truck drivers. So the actual numbers of companies that are employing truck drivers is even higher. Right now, there are about 45,000 open positions listed with the German Arbeitsagentur. If you ask a trucking company whether they find their driver at the German Arbeitsagentur, they will laugh at you. They won't. So this is just the officially listed number. The actual numbers are probably far higher. So it's harder to find a truck driver than a software developer. Yeah, you laugh, but it's true. There are actually logistic chains breaking because of the missing drivers, because trucking companies don't have drivers anymore. If you're working in that field, you get some weird comments like, hey, the consumers shouldn't expect to always have melons at the supermarket. That's just plain stupid. We can't support that anymore. We don't have the drivers for that. I got one guy saying, I was wondering last Christmas why Amazon Prime was still able to deliver. I was expecting it to break down because of a lack of drivers, but maybe next time. And the large company is saying, hey, our parcels didn't get delivered anymore because our subcontractor didn't have any drivers left. Now we are trying to hire drivers ourselves. Good luck. Not that easy. So this is the domain we are tackling. Of course, we don't propose to solve all those problems. But there's a heavy drag on the economy if drivers frequently change the job. And they do that. They change their job sometimes 3 or 4 times a year until they find a company they like. And then they stick to that company. But of course, every change is a drag on the economy, and we can help that. We can make the allocation better. We can provide them better options of choosing a decent employer. So that's what we are trying to do, and we offer a marketplace for drivers and trucking companies, the 2 websites I showed you before. Now, we sometimes consider ourselves to be a little bit like Parship for the trucking community. There's not that much love involved, at least not yet. Maybe that will change at some point. So we match drivers according to job offers according to their capabilities and preferences. We do matching. Now, that still doesn't have to do that much with event sourcing, something like that. But let's look at the technical details. Well, when we started that, I made something that I consider to be my initial SQL assumption. Like, there's a driver, he wants a certain income. There's a job that provides a certain income. The driver lives at a certain location, wants to work there. The job takes place at a certain location, and the driver has some licenses that allow him to drive this huge truck, and the job requires certain licenses in order to allow that driver to do his job. Well, of course, I was completely wrong. That was too simple. Look at things like location. The driver may be on the road for a whole week. So if he's living in Berlin and working for a company in Munich, it doesn't matter to him. Munich pays much better than Berlin. If you ever want to work as a truck driver, go there. But of course, the location is not important in that case. Of course, there are other drivers which want to be home with the family every night. There are truck drivers that even told me they are happy if they see their wife every second weekend. Models are different. Income, it's not just a number. They get a base fee, yeah. They get allowances, Spesen, because they are traveling. They get a bonus for working at the night, at the weekend. They get a bonus if they don't hit anything with the truck, yeah, good thing. They get a bonus for having a clean truck and for Christmas and so on. So it's really complex. Sometimes the companies don't even know what they actually pay to the driver. It's amazing how the system works. But it's not a simple attribute like I imagined at the beginning. And what do I need for matching? Now, could I match you if you wanted to have a job as a truck driver? Of course, why not? I mean, I'm in Berlin here, so I could offer you jobs in Berlin. Might not be the perfect match for you. I don't know if you even have the license for that. But quite essentially, I don't need any attributes to match anything. It might not be a good match. It's better if I have more knowledge. But yeah, I can match you. So attributes may be missing. And sometimes the attributes are just roughly matching. Like I said, with the location, the driver says, I want to be home at night. The job offer says, you have to travel 1,000 kilometers per day. So that's just a weak coupling between those attributes. And frankly, we don't know. This is an evolving product. It's a complex task. So we still need to learn a lot. The attributes will evolve over time. We still have to refine the questions we are asking to the driver. Is it more like we should ask, do you want to drive in the regional area? Or is it the question, do you want to be home at night? Stuff like that. That will change over time, so attributes will change over time. All that sounds a lot more like NoSQL or not structured data. But there's even more. When we completely ditched the initial SQL database, I did. I had to get rid of that. I did do some domain-driven design, event storming, to get a better view of the business concepts we were working with. It's actually a bit more complex than the 2 aggregates I showed here. An aggregate in domain-driven design is like can be a simple object, but usually it's a combination of some objects that are consistent together, that are in consistent state. And we actually don't look at driver and job. This is something I only did for the talk. We are actually looking at driver and business customer, and the business customer is a set of different objects, like has several job offers and stuff like that. But in general, I can simplify it to that. I have a driver and a job. Those are the two main aggregates we are working with. And of course, these can change. The driver, that has not that much change. Of course, he registers with our website, but there might be some change later when we learn, okay, the income he actually provided on the website wasn't quite that right. He wants lower or higher income. So we see that there, when we have the contact with him, maybe by phone, maybe by mail or whatever, we learn that we can do better in the product in order to find better matches for him. So that's a relevant thing that changes on the driver. Of course, the job is more long-living. The companies will hire several drivers for the same job type. So there's a lot more change there. We actually sometimes tell the companies, hey, if you don't get any drivers from us, maybe you just raise the salary. So they change the job type. And there are actually, a set of events on those aggregates that change the state of these aggregates. And then we match. We already match now, meaning we provide or form a match at a certain point in time, at a certain revision of those aggregates, and say, yeah, at that time, that looked like a good match. And then maybe a year later, we learn, hey, the driver's still at that company. So that was probably a good match. And that's information we can learn from. And when I looked at that, I realized, yeah, actually, I think I want to use event sourcing. I want to have a log, a time-based log of the events on the aggregates in order to be later be able to, in retrospect, learn from the stuff we did, from the matches that were good. That were the reasons for going into event sourcing. So our core decisions were to use event sourcing for, on one hand, flexible data structures, because you can basically place anything within the event, and to learn from the matches. And we chose AWS, Amazon Web Services, for a flexible base for our implementation that provides a rich tool belt from which we can pick stuff and quickly build our product for the high availability. Of course, that's just an implementation detail. We could use any cloud provider, you can use your own hardware, but of course many people choose Amazon Web Services, so I think it's reasonable to show how we actually implemented this system, this event sourcing system based on Amazon. Now, this is the rough overview. Now I'm going to go into the technical details. I briefly need to ask who is not familiar with the constructs I display here. Should I briefly go through the different AWS systems here? No? Everyone fine? Oh, a bit of, okay, short. API gateway is an HTTP endpoint. It receives requests from the outside world. The orange thing, the lambdas, are cloud-based functions that react to events, to outside events. For example, here for the HTTP event, the dynamodb is an AWS NoSQL database. S3 backup is file-based storage. And the Redis cache is just Redis, also a NoSQL database, a key value store for fast retrieval of objects. That's what we are using in the core. Of course, there's additional stuff around it, but this is what I'm going to focus on now. I'm not going through this in total. I'm going to split it because, of course, this is a command query responsibility segregation type of thing, meaning there's a write side and there's a read side. I'm going to focus on the write side first. So what's happening there? Well, for example, here I have a job and I want to add a contact to that job. Like that might be the contact receiving the driver profiles. So the browser is posting a new contact to this job, identified by this UUID. This job is an aggregate, and this is a simple HTTP request, which ends at the yellow API gateway. This takes the HTTP request and triggers a lambda, the orange thing. That lambda considers this to be a command that is acting on the aggregate, a command to the aggregate. Now, the purpose of the lambda is to check whether this command is actually valid. Am I able to add a contact to this job? If so, yeah, convert the command into an event and store that event in the event log, actually in the dynamodb, and that event log is internal. It's just being always added. You always add event, you never delete them, it's just growing in size. So much for that. How does this look in detail? The Lambda initially takes that HTTP request. We are using JavaScript everywhere. I'm going to go into that, why we're doing that later. Here you have to accept that I'm using JavaScript. It's just pseudocode. It's a very simplified Lambda situation. It's also only the start of the Lambda. We are looking at the kind of the entry point where the HTTP request gets converted into the command. I hope it's readable. So what we are doing here is we define a Lambda. This receives some kind of Lambda command or Lambda event. It's sometimes named, but in this event sourcing thing, it's strange if that would be named event. So you receive the Lambda command, and that from that you take the HTTP path parameters, which here is the job ID that identifies the job aggregate that this command should act upon. And then you construct a command, which is a simple object. It's just named @jobContact. That's what you want to do, what the command actually is about. You define the aggregate with the ID, and the name of the aggregate is job, because that's the aggregate we work upon. And you take the payload. Here, I just take the whole HTTP body as payload for the command. That's a bit unusual and unrestricted. You can do it, but usually it looks a bit more complex. You actually have some schema or select certain attributes. But for simplicity's sake here, let it be the whole body of the HTTP request. Now you have that command, and you stuff it into this magic write domain function. In the JavaScript world, the best library for CQRS event sourcing stuff I found was the one from CQRS.js.org. We are using that for our event sourcing library, or here the CQRS domain part for the command for the write side. It's the best library I found. The only downside is the documentation. If I ever find the time to document or write some blog posts about it, I will. But so this way it's somewhat hard to use, actually. But I still like it. You'll have to see for yourself. The documentation is really a bit weird. Anyhow, we use that as a base, and within that package, you just say, okay, if you have an incoming command, you have a command handler. This @jobContact.js here, up there. That's stored. You have many of those, of course. Each one file per command. And the stuff can be rather simple. The task of the command handler is to see whether that command can actually be applied to the aggregate, the job you want to act upon. Now, so you have to check some business rules. The one I have here is extremely simple. This is this existing true. Yeah, the job should exist before you add a contact. Makes sense? It's a very simple business rule, just for demonstrating this. There can be more complex business rules, obviously. Given that that business rule holds, the job exists, I am able to add a contact. Now I convert the command into an event. So you get the command here, you have the current state of the aggregate, and you say, okay, now I'm making an event out of that. If somebody ever did event storming, this is a typical pattern. You say, okay, you have a command like @jobContact on the aggregate, and what you derive from that is something in past tense. It has happened, added job contact. So that's the name of the event here. Typical scheme of this command event thing. And here I'm also being very simple. I just take the command payload and put it into the event payload. Pretty horrible, just from the HTTP body into the event body, but anyhow, simple enough here. One thing that you still have to do so that you can check the next command that comes in is to apply that event to the aggregate. It's not really necessary in principle at that point. When you derive the event from the command, you can store your event in the event log, meaning in the dynamodb down here, and you don't have to do anything else. But let's assume that you actually have a business rule like checking for duplicate context or something like that. then you need to know what is the new state of the aggregate so that when the next command comes in, you can actually check, okay, is there a duplicate contact? No, then the command is not allowed, I'm rejecting it. So there's a last handler that is applying the new event on the aggregate within the right side, but it's not strictly necessary. If there's no business rule checking for duplicate contexts, I could also leave that out. So much for the right side. What are the disadvantages of this approach? Well, for one thing, it's consumption only. It's like, yeah, I heard you, I understand the command, yeah, command is valid, I take it, that's it, go somewhere else. Look at a status monitor, HTTP 202. Your front-end developers might not like it that much. I'm a front-end developer, I can live with that, it's okay. And I think it's also not really a problem, but you have to keep it in mind. Consumption only. And well, you have one command, one lambda, you have one log in Amazon CloudWatch, one command definition, one event definition. How complex is your domain? How many of those will you get? For us, it's still manageable. Well, if it's a very, very complex domain with many, many aggregates, I don't know where we end up in a few years. I don't know, maybe a bit too much. But of course, there are advantages as well. Otherwise, we wouldn't use it. So data structures can be really relaxed, like what I showed you. HTTP body ends up in the event body. That's cool when you start. The product rules. The guys in the front end can do whatever they want. They can store whatever they want in the back end, basically in the VNs. That's nice for a start, but maybe later you want to restrict by schemas. But that's possible. You can get more and more strict in what you accept within your backend. The incoming data can be mangled on different levels. You can do that when the HTTP request comes in, convert it into command data. You can do that on that level. You can change the data when it is converted from command to event, wherever you like. And it supports the domain-driven design approach. We're actually talking about real-world events here. Like, okay, adding a contact to a job is maybe not that real-world, but we have events like a start driver call, stop driver call, or add a new driver, match a driver, stuff like that. Real stuff people, sales agents, are doing in our company. And I like that. Now, that was the right side. What I didn't talk about was the backup. I think it's a nice side effect or feature that you can actually export your whole event log to the S3 backup and do data analysis locally. You can run the event projections on that event log, but that's more like a nice thing to have on a side. The read side. Well, you could not just take this whole event log and push it to the browser. That would be bad. Even we, as a small company, I think we have a few 100,000 events already. So that's not something you want to push to the browser. So what you need to obviously do is take those events and project them into readable, usable views, more like what you are used to from an SQL database or some JSON object or whatever. But it needs to be deserialized in a certain way. You need to denormalize or project these events. So what's happening there is that on each event that gets stored in the dynamodb, you trigger another lambda, the orange thing up there. It will fetch the current view from Redis. It will apply the new event to the view and store the updated view in Redis again. Simple enough, but very, very efficient. The views are always up to date. With each new incoming event, you have an updated view. Well, that's pretty efficient data handling. And you store that in Redis. Now you have your views in Redis. You can have many of those pipelines, many different view definitions, also for different purposes. You can have them for the front end. You can have them for data analysis, whatever you like. There can be several pipelines. And also for different aggregates. Now from that Redis, you have two options. The natural thing is like the push model, where I say, okay, I got a new updated view. Now, I push a notification to the Redis. It travels somehow by WebSocket to the web browser, the updated view. I depicted the somewhat simpler setup with the pull situation, where the browser is actually saying, okay, get me the new job, like get the job with it with this UUID from Redis, and either you have a Lambda aggregating a few different views and providing a response. It could directly provide the Redis object to the front end, whatever you like. The front end can also access different or a variety of resources and aggregate its own data view. So there are a variety of options. Again, we are using a library from CQRSJS.org. This is the read side, the CQRS Event Denormalizer. And how does this look like? Again, you have a handler per event. Like here, I'm on the driver side. These are actual events we have in our system, like added the driver, add a comment to a driver, blacklist the driver, or delete him, or edit, postpone, send driver message, started driver call, stop driver call, stuff like that. Real-world actions that our sales agents actually perform. How is the event converted into a view model? Well, this is the first simple event where you just add a driver. That's extremely simple. You just say, okay, this view builder is handling an event named added driver. It is acting on an aggregate that's named driver, and you take the whole event payload, again, a bit simple, and you create the view model from that payload. That's what you say here. Just take the whole event payload, create the view model in the same way. Usually the event handlers are a bit more complex, like this one. This is still simple, where we postpone a driver because he's not yet finished with his license, and we can only provide him in a job like in 3 months or something like that. Then you say, okay, the event name is postpone driver, working on the driver aggregate. You again take the whole event payload. You get the payload here in this data thing. You have the view model here, and on the view model, you set the wait until attribute with a timestamp from the event data. Realistic example, maybe. So how to deliver views from Redis? Again, I only show the pull model. That's a bit more simple here. You have another Lambda, that one here. I only show a simple situation where you request a driver object from the Redis cache. So you again get a command, the Lambda command, and then Lambda callback. You extract the driver ID from the path parameters. You access the Redis store and ask for a driver with that driver ID. You get, hopefully, a JSON result, which you just return to the front end. Simple enough. The push situation where you push the view model to the front end is a bit more involved because you need WebSockets and stuff like that. It's not quite that easy on AWS, but it's possible. What are the disadvantages of the read side? Well, pretty much all the downsides of handling an event log. If some of you were here at Kandinsky 2017, that was also taking place here. There was one talk that dealt with all the problems of event sourcing and the event log. Basically, you may have problems like, well, there are really old events that you did initially, or you changed the version of the event, or if you used the scheme that I told you about before, where the product rules and actually can choose what kind of stuff it is storing in the events, then you might pile up a little bit of garbage, which can be problematic. And usually an event log is eternal and you don't necessarily clean it up. You can, but so there are a number of approaches to deal with that. Everything of that is possible, but it also has some downsides to have such a huge event log. At some point, if it's really getting huge, it might take weeks to establish new views from that if you actually change your view builder, stuff like that. There are some problems in that area that you can that can occur. And providing or developing such a view actually requires coding the view builder, so the event denormalizers. It's not like you have your simple SQL with the pre-built schema, or you join some views via some simple SQL statements. You actually have to code this stuff. This may be simple, but it can also be somewhat more complex. So you have to take that into account. It's a very efficient approach, I think, but it still takes coding. And of course, you have an asynchronous pipeline by default. We are in the modern world. Every front end can deal with that. It's not much of a problem, still you have to take it into account. So, the advantages of the read side. Well, the response data can be built on different levels. And that, to me, is a major advantage, and also the reason why I expect our developers to work on all levels, to be really full stack and to work with, if possible, with JavaScript on each level. Of course, you can break that maybe later, but at the moment, for us, it's an ideal situation if the developers can work on the whole stack. You can build the event, the view data up on top in the event denormalization. You can mangle the data when fetching it from the Redis cache, but you can also do it in the front end. And if you're a startup, you're just building your product. You are trying out different things. You need to determine what actually works and what does not work. And it's a nice situation if the product actually rules and you just hack something together in the front end and you test it with the customer. And if you see after 2 months that it's actually working, but you realize, oh, I'm doing 10 requests to build up my data view, that's maybe a bit too much. Let's push it on the next level. Let's push it from the front end to the first Lambda and fetch the views from Redis and only do 1 request, but maybe fetch 5 different views from the Redis cache. And once you learn that is not even enough, you can push it down to the last level, to the event denormalization. Maybe the most work in terms of coding, but you can go step by step and get an even better optimized system, which I like a lot. The system is scalable by default. There are many interfaces where you can actually scale. You can have different view pipelines. You do not have to have only Redis. You can have different databases, whatever you like. So if your startup explodes, hoping for that, you should be fine, hopefully. Push model by default, I like that. Pushing notifications to the web front end is something I think that's a reasonable, sensible thing to do. Yeah, that was the right side. And I made the full circle. That is the system we established and that we work with. Just to briefly summarize, in total, what I see as the disadvantages of the system. Well, it's command query responsibility segregation. So there is a read and a write side, and they're separate, and that may be slow. I push in the command, the event travels through different lambdas until there is a view. That's fine, doable, but in the front end, you sometimes, or early, may also occur in the situation where you want to do stuff like optimistic updates. Yeah, the user clicked, and yeah, everything fine. And meanwhile, there's some background process checking whether everything really worked out fine and the command actually was accepted. Maybe a downside. There are many bits and pieces. I mean, it's not like there's just one thing, one database sitting there. There are lambdas and dynamodbs and whatever, and they need to work together. So maybe a downside. And it can be, as I said, garbage in, garbage out. If you really accept anything in your events, well, yeah, at some point, you probably lose oversight. What did you actually put into your event log? Is that still something you can decently analyze or not? Did you version your event? How did the product evolve? You still need to keep track of that. So, of course, you can deal with it, but you need to be careful. What are the advantages? Well, what I initially said what we wanted to have was a flexible system. Yeah, you can mangle data anywhere. What we put in, what we actually take out of that, it's easy to change on any level depending on how the product actually evolves. And the front end, the product, may actually rule the whole thing. It's not the back end ruling things. It's our understanding of the business domain, the product we provide actually rules how the code looks and how we optimize. And that's something I like. It's scalable. Yeah, it's also necessary when we want to be flexible. In terms of learning, I consider this to be a decent system to enable learning from day one. Because you collect a lot of events, you have this temporal sequence of events on the aggregates, and you can later look at what actually happened with my aggregates. If you're about to learn, yeah, this should help. And it actually makes your data analysts happy. I have 2 of them, and they are really happy and seldom angry with me. So that's a good thing. And it deals with real-world events. It makes it a lot easier to actually understand the data, understand what the data is about. Yeah, and with this, I'm already finished. I was a bit too fast, sorry for that, but I thank you for your attention.
So, I think we've got some time left for questions. Yeah. Oh, there are many questions. Okay, let me start here. Thank you for your interesting presentation. I have one question. You use Redis for storing your read model, as far as I understand. But what happens if, for instance, your Redis cluster goes down? How you recover your read model after it? Because all data is stored in memory, as far as I understand.
Well, I mean, this is Amazon. You have a backup, you have redundant
for Redis?
Yeah. A backup in Amazon? Yeah, sure.
But
and you have it can be redundant as well. I mean,
but are you sure that after restoring backup, the consistency between between read and write model is kept?
Yeah, I mean, the Redis actually once break down. We recovered without any problem. But even if that would be a longer period, then you would do a replay, right? You would replay your whole event log through the event denormalizers and just rebuild. This is something you can always throw away. It doesn't matter. It's just
that's my next question. Do you use do you use any snapshots to short on this rebuild of read model process?
Not yet, because we are still small. Even if we have a few 100,000 events, the replay is still pretty fast. I started with a very simple replay. What replay is when you take the whole event log, run it through all event denormalizers, and rebuild the whole Redis store or the whole view, all view models together from your event log. That's something from which you can always fully recover, and something you might even need to do when you change the event denormalizers and want to establish the views in a different way. So I know that for Zalando, Felix once told me it took a week for a replay. We are not yet there. It's 5 minutes for us. So we are still fine. But I know that this will happen at some point in time. I need to have a better replay then.
Okay.
Yeah.
As I understood, you use the view lambda to provide the browser with push notifications.
Yeah.
Is that true so far? So can you explain why you use the view lambda for actively getting data from the Redis store?
Both are possible models, pull and push. The natural model is pushing via WebSocket, but it's not that simple on AWS. You can do that, it's all fine, but for this presentation I just showed the pull model. Both are possible. But the push model is somewhat nicer because then you can, but it depends on the use case, right? I mean, for our internal system where the sales agents cooperate, it's better to have this WebSocket approach so that they know, okay, this drive was already matched. I don't need to do anything on him, stuff like that. But for other situations, I like the pull model more, where it's not that important to have up-to-the-minute updated notifications. Then the browser just does a get, and that's the situation I showed here.
Yeah, I understood that, but my question was actually, why do you use the Lambda for getting data? You could also directly talk to the Redis cache. So
because I usually do more than what I showed here. Usually I'm not directly serving the simple JSON blob. Usually my web front end needs some more stuff around. But okay, yeah, could do that.
Actually, I had two questions, one for the snapshotting, so that's one it's done, and the versioning. Did you have the situation where you had to have a second version or third version from the same?
I didn't use that yet, I'm honest. But it's all possible within that CQRS ES framework. But yeah, so far my data analysts didn't get angry enough with me, and we were still able to understand when we changed the product so that the events change. But in principle, it's all there, and I know we should do it. But there's only so much time in a startup.
Okay, hi, thanks for your talk and the insights. Two fast questions. First one, because there's not so good documentation for the JavaScript CQRS library. Is it possible to use other storage systems, like other ones like dynamodb and Redis, or is this just built into the...
Those were the easiest ones for me to use. There are other options as well. This thing can run on Azure. You can look up the documentation on that site to get a better overview. There are different options, but there are not that many. And I think, basically, if you're bigger, you should probably just use some decent Java library. But right now, I like it when my front-end developers are able to go to
And this brings me to the last question. Do you think you need backend engineers at all? Because, I mean, backend here is commodity, and you can just do it as front-end engineer and mingle together the Lambda functions. And how do you evaluate the situation from your point of view in 3 years?
It depends on the type of developer, right? I mean, I had developers that had trouble with, which were more familiar with the CSS and JS situation on the front end, and which were a little bit uncomfortable with looking at the event denormalizers. But at the moment, I also have two which really like that stuff. So it depends a little bit on the developer, I would say. But yeah, ideally, I just have a full stack guy and like that.
I have a bit naive question, maybe. The DynamoDB stores really events, no data models in the classical sense.
No, it stores events, yeah. This CQRSJS.org has a certain structure, how it stores that in a NoSQL database, but the core event is just a JSON blob. This library just uses some additional fields like commit stamps and aggregate name in order to be fast on that event log when it retrieves the events for an aggregate.
So, I have a question here.
Yeah.
I have a question about the right side. Why do you have to apply the events to the aggregate? I mean,
at the end? Because there's a next command coming in.
In the same Lambda? I thought the Lambda is gone after this execution, and you have to...
No, then I depicted it a bit incorrect, because all three steps here, this one, and this one, they are all happening in that orange Lambda. But this one here, this part, is just the HTTP part, and within that write domain function, you are actually having this library, and that will call add job contact for the command to event conversion, and you will have the event handler that automatically, after the command to event conversion, applies the event to the aggregate. But maybe that's a bit more complex, and we should maybe later look at some code. I'm still there, so.
Okay, anyone else? Did you have any problems with concurrent execution of Lambda functions? For example, if they run twice because they failed, or if they run out of order, so you receive your events out of order, or things like that?
No, I think that the approach we are having there is the library is pretty resilient to such problems. I did have issues with the denormalizers sometimes, because I coded it incorrectly and had some problems with promises and stuff like that. But that was my own fault. The library itself is pretty resilient when it comes to that, because of course there's handling for ensuring that the sequence of events really occurs one after the other. So it's not like you can have the one command colliding with another command. They happen one after the other. There's specific code that ensures for that, but that is standard stuff I would expect in any event sourcing library.
Relate to previous question, but how you manage concurrency? For example, does your system support, for example, optimistic concurrency or somewhat?
Well, I mean, there's one command after the other.
But what happens if both commands try to change the same aggregate in the same state?
One will win.
But how?
The first one. Simple.
How?
Well, if there's a business rule that says on the second command you're not allowed anymore because you try to change the same thing, then it will be rejected.
But how it happens? From my point of view, it is optimistic concurrency. But how do you implement? How did you implement this?
This is not something we implemented. This is something that's part of that library because, or this is part of actual of this aggregate concept. An aggregate has always to be in consistent state. If you fail at that point, the whole thing doesn't make much sense. So these commands come in one after the other. It's
so you mean that optimistic concurrency implemented in the library, yeah?
Yeah, I would say so, but maybe we should also talk to because I think I don't fully understand your question, maybe.
You mentioned event store. What kind of events are stored there? I mean, the initial one that enters your system, or the all
events. An event log carries all events in our domain.
So if you want to reply the state or current state of your system by replying the all past events, then how do you get it? I mean, because if you run one event, it can trigger another one, and there is a chain.
No. Events don't trigger events.
Okay.
In event sourcing, no go. An event is something that comes from a command. And then it's written to the event log, and then it stays there. It's not like one event triggers another event. A command can be converted into an event. The command is add the job offer contact, and the event is added job offer contact, but it's not like you derive a second event from that.
And in the architecture that was depicted in that picture, there is one event store, or
yeah, this one. At the moment, we have one.
One for the whole system.
Yeah, of course, in order to scale later, you would have several ones.
One more question. If you at some point add another event, so how can you make sure that the overall global order of events is preserved?
No, the event order is important per aggregate. So okay. you cannot have.
Okay, so you would basically
split on
slice
the
them on aggregate. Okay. Any more questions? Okay. Thank you very much, Gunnar.
Thank you.